Hi everyone, this is Math Sunshine with the geometry lesson on points, lines, planes, segments, and rays. Let's get started with some vocabulary. The first term that we're going to discuss is plane. A plane is a flat surface that's infinitely large and has no thickness. I like to think of a plane as being similar to a piece of paper. A piece of paper is flat, but also you need to imagine that the paper continues on forever in all directions. And when we represent a plane using a picture, we draw it as a parallelogram with a script or cursive letter in the corner here. And in this case, we would call this plane M, using that cursive letter M there. Plane M. Or we could choose 3 points that lie in the plane to name it. So we could call this plane TUV. Or we could switch up the order of those 3 points. So we could also call it plane UTV. Or we could call it plane VUT. You get the idea. Let's go on to point. A point is an exact location or position on a plane. When you read a map, all of the cities are indicated with points to show you that that's a location. And in this case, our example is a point with the letter Q underneath, and we would call this point Q. The next term that we're going to discuss is line. A line is a one-dimensional figure that extends forever in both directions. And here's an example. And in this particular example, you'll notice that there is a lowercase letter h next to the line because we could call this line H. Or we could choose 2 points that are on the line and name the line that way. It doesn't matter which 2 points. So we could call this line KP. Or we could call it line XK. Or we could express this name symbolically, choosing 2 points and then putting the symbol for a line on top of those 2 points. So we could choose K and X and put a line symbol on top. KX. And then the symbol for a line is a line with arrows on both ends. Okay? Or we could call this PX with the line symbol on top. A line segment is just a piece of a line. It's part of a line that has 2 endpoints. So it's just part of a line. It's not the whole line. And notice that the line segment does not have arrows on it because it stops at its endpoints, the points on the end. Okay, so we could call this or name it using the 2 endpoints. We would name this segment SR or segment RS. Or using symbols, we could write down RS with the segment symbol on top. RS. The segment symbol is just a line with no arrows. Or same thing, SR with a segment symbol on top. Here's the last term that we'll discuss. This is ray. A ray is part of a line that starts at a point and extends forever in only one direction. Okay? And in our example, that ray begins at this endpoint D and then continues on forever toward where the arrow is pointing, towards me. Okay? We would start by naming this using the end point, the point on the end, D. So we could call this ray DW. Or symbolically, we'd write down capital D, capital W, and we put the symbol for a ray on top. And the symbol for array is just an arrow that points to the right. Symbolically, we always use an arrow that points to the right, even if the line, or even if the ray points the other way. We always use this arrow pointing to the right. Let's take a look at example 1. Example 1 is going to give you just a little bit more practice on naming figures. The directions say, name each figure using words and symbols. If possible, give multiple answers. On letter A, this is a segment. We could call it segment JK. Or segment KJ. Or symbolically, capital J, capital K with the symbol for a segment on top, a line with no arrows, or KJ with the same symbol on top. Here's letter B. Letter B is a ray, and it's ray BL. Or you could write down capital B, capital L. Put the symbol for a ray on top of those letters. It's an arrow pointing to the right. You cannot call this ray LB because L is not the end point. The first letter you write down has to be the point on the end point. Okay? Letter C. This is a point. We will call it point R. Let's look at letter D. Letter D is a figure with arrows on both ends, so letter D is a line. This is line C. Okay? Or you could choose 2 points on the line. You could call it line XY. Or you could call it line XZ. Or you could write down XZ with a line with arrows on top to express it symbolically, or ZX with that same symbol. Okay, letter E. Letter E is a plane. We could call it plane S using that letter in the corner there, plane S. Or choosing 3 points in the plane, we could call this plane GHI. Or GIH, or HIG. And then the last one here is F. F is a ray, and we would call it ray MA. We cannot call it ray AM. We have to call it ray MA. Okay, or we could write down those 2 letters, M and A, and put the symbol for a ray on top. Always an arrow pointing to the right. Here are some notes that I'd like for us to discuss. The first says, points that lie on the same line are called collinear. Any 2 points are collinear. Okay, so collinear is an important vocabulary term for us to talk about. The reason why any 2 points are collinear on the same line is because I can always draw a line that goes through 2 points. When I have 3 or 4 or more points, I might not be able to draw a line that goes through them. For example, these 3 points are not collinear, and the reason why they're not collinear is because I can't draw a line that goes through those 3 points. But these 3 points are collinear because I can draw a line that goes through them. Okay, so that's collinear. The next bullet point says coplanar points lie in the same plane. Any 3 points are coplanar. Okay, now the reason why any 3 points are coplanar is because if I have 3 points, I can always draw a plane that goes through them. Okay, for example, watch what I'm doing here. There's a point here, here, and here. I can draw a plane that slices through those 3 points. There's a point here, here, and here. I can draw a plane that slices through those 3 points. When you have 4 or 5 or more points, they might not be coplanar, but 3 points are always coplanar. Okay? Planes are named using 3 non-collinear points. Now we talked about naming planes using 3 points, but we didn't mention the fact that they have to be non-collinear until now. And the reason why is because there will always be a unique plane that passes through non-collinear points. But if you have 3 collinear points, there's an infinite number of planes that can pass through those 3 points. You can have a plane going this way, vertically, horizontally, angled this way, angled that way, angled an infinite number of ways. So we want to name planes in the most unique way possible. So that's why we use non-collinear points. And the last bullet point is talking about opposite rays. Opposite rays share a common endpoint but extend in opposite directions. Okay, so here's an example of opposite rays. Let's say we have ray RB. Okay, that's our ray. And it's pointing to the right. Okay, an opposite ray would also begin with this endpoint, shares a common endpoint, R. Begins with R, but it's going to go to the left instead. Okay, so ray RC. So rays RB and RC are opposite rays. Let's do another example together. Here's example 2. Example 2 says, use the figure to complete the exercises below. Letter A says, are the points G, K, and H collinear? Let's look at that figure. G, K, and H. Here's points G, K, and H. Looks like all 3 are on line E, so yes, they are collinear. The answer is yes. Letter B says, are points F, G, M, and K coplanar? Now remember, any 3 points are always coplanar, but after that, once you have 4 points, they might not be coplanar. And this is 4 points. So let's find F, G, M, and K. F is up here, G, M, and K. Now G, M, and K all lie in plane W, but F does not. So no, these points are not coplanar. Okay? Letter C says, are points F, G, and M coplanar? Remember, 3 points are always coplanar. So the answer is yes. 1, 2, 3. That's 3 points. Now look at that diagram over there. F is here, G, and M. You'll notice that F, G, and M do not all lie in plane W. F is not in plane W. But theoretically, there is a plane that contains F, G, and M. It's just not drawn on that diagram. So that's why the answer is yes. Letter D says, name a pair of opposite rays. Okay? I'm looking for some rays. Looks like we're going to find those opposite rays over here. So starting with K, because K is in the middle of G and H, we've got ray KH. And we need a ray that also begins with K and goes in the opposite direction, KG. We have one more example to do. Let's take a look at example 3. Example 3 says, use the figure to complete the exercises. Let's look at that figure for just a minute before we take a look at the exercises. So this figure has 2 planes and they are intersecting each other. You're going to have to imagine that this orange plane is kind of like this piece of paper and it's slicing through the other plane. Any of the lines that you see that are dashed, those are in the background. Any of the lines that you see that are solid, those are supposed to be in the foreground, in the front. And that will help you to understand what's happening in this diagram. Okay, letter A says, name a point that is not collinear with points A and C. Okay, so let's find A and C. Point A is here, point C is here. We need any point except Z. Z is collinear with those 2. So we could say point Y, point X, or point R. Any of those answers is correct, so I will write down point Y. Not collinear with A and C. All right, letter B says, give another name for plane B. We have to choose 3 points that are in plane B that are not in a straight line. Okay, so we could call this plane YXZ. The only name that we cannot give plane B is we cannot call it plane AZC or any of those 3 letters. Okay? Letter C says, what is another name for plane H? It's the same as letter B. We have to choose 3 points that are not in a straight line that are in plane H. Okay, so we cannot call it plane AZC. We have to call it maybe plane AZR. All right. And then letter D says, name the intersection of plane H and plane B. Okay, so let me see here. Plane H and plane B cross each other, and planes always intersect at a line. Okay, so this line is where the 2 planes intersect. And we could call this line AC if we wanted to. Here's the practice section. Pause the video now and try these on your own paper. Now that you've had some time to try these on your own paper, let's talk about problem number 1. It says, name each figure using words and symbols. Give as many answers as you can. Okay, letter A is a line. We call it line Q or line PE or line EP. Or we could name it symbolically PE with the symbol for a line on top, or EP. All right. Letter B is a ray. It's ray ZN. Or symbolically ZN with the symbol for a ray on top. Letter C is a plane. This is plane D. Or plane TNX. Or XNT. Letter D is a segment. This is segment DJ. Or segment JD. Or symbolically DJ or JD with the symbol for a segment on top. Number 2 says, use the figure to complete the exercises below. Letter A asks you, are BR and RB opposite rays? Why or why not? Okay, so here's BR, starts at B and comes this way. RB begins at R and goes that way. So they go in opposite directions, but they do not begin with the same endpoint. So no, they are not opposite rays. No, they aren't opposite rays. Because they don't begin with the same endpoint. Okay, and then here's the last item. Says, letter B says, name the intersection of line F and plane K. Okay, so here's plane K, and here's line F. And you'll notice that part of line F is dashed. And that's because this portion of line F is behind the plane. Okay, so imagine that line F is coming towards the plane, touching at point A, and then going behind it, which means the intersection is point A. So the answer here is point A. Thanks for watching this video. If you liked it, remember to hit the subscribe button. See you next time.